Simple linear regression using matrix. So we're going to use matrix to solve this simple linear regression. Simple linear regression model is giving us so y equals to alpha, or let's say plus beta x, where alpha is the coefficient, beta is also the coefficient. Alpha is a constant and beta is the slope. So then we have a plus error term. So we have a I subscript I, x subscript I subscript I. Because we have it that y is a series of random variable, or x is a series of numerical value, and we have the error term too. Now, assuming that assumption of regression fulfilled, then using the matrix notice, we have y equals to say x beta. We have y equals to x beta, where y and x are the variables. Then we have the beta to be what? To be the coefficient. Now this y now in matrix notation run from say y1, y2, dot 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 up to yk. So we're going to have a series of variables. The x is going to be, and if you do not forget, in writing this, you can write it as y equals to beta naught plus beta 1 x. Now the coefficient here and the coefficient here, you can see there is no random variable here. So there is no variable here, there is no variable, we have constant. So therefore we have the matrix to be 1 1 dot dot dot. So it's still 1. Then for the x part, we have x1, x2, dot dot dot, we have xk. Then for the beta, we have this as this. So beta naught, beta 1, dot dot dot, beta k. So this is a matrix notation of simple linear regression we are going to be used now. So, and for us to get this beta, we then beta equals to x prime multiplied by x, everything inverse, multiplied by x prime y. So we have x prime x inverse multiplied by x prime y, and this is going to give us the coefficient of this simple linear regression, which is a beta naught and beta 1. Now let's look at an example in order to understand this beta. So now we're going to use this example, calculate the regression coefficient and obtain the line of regression from the data below. So we have an x column, we have an x row, we have a y row. Those are the values of x and these are the value of y. So if you remember, our beta, let's say the coefficient of our regression is we said y equals to x beta. Y equals to x beta. Now our beta, for us to get this beta, we say beta equals to x prime x inverse multiplied by x prime y. So this is how we can get our beta, and this is equals to, it will give us all the values of the coefficients, so beta naught and beta 1, since we are dealing with simple linear regression. Now what are the value of x? What are the value of x? So x, as you know, say, like we saw the other time, that here we have this notation of x to be 1 x 1 1, because here we have the coefficient of x to be 1 and the other coefficient of x, we have the coefficient of beta naught to be 1 and the coefficient of beta 1 here to be x, and x as our variables. So we have 1 1 1 1 1 2 3 4 5, because we have 5 series of number 1 2 3 4 5. So the other side here we have 2 5 6 8 11. This is our our x. Now our x prime will be equals to, that is the transpose of this x. The column here becomes the row, and the row becomes the column. So here we have a 1, 2, 3, 4, 5, and this becomes the row. It is a 2, 5, 6, 8, 11. Now we need to multiply x prime x. Now I want to multiply these together in order to get the other matrix the same. X prime x equals to, that is to multiply this by this. And what are we going to have? Same this it here. So 1, 1, 1, 1, 1, 2, 5, 6, 8, 11. The multiply this matrix here, x is a 1, 2, 3, 4, 5. Now we have a 2, 5, 6, 8, 11. So can we see that now? Now we're now going to multiply this by this, by this. Multiply this by this. If you multiply that by that, we're going to have 1 times 1, 1 times 1, 1 times 1, 1 times 1. Everything is going to be 1 plus 1 plus 1 plus 1 plus 1. So that's what we're going to have here. Now we are still using the same row here to multiply this column. 1 times 2, 1 times 5, 1 times 6, and this is going to give us 2 plus 5 plus 6 plus 8 plus 11. So we use the first row here to get our first row here. Now we're going to use this second row to multiply the first column here. Then later we're going to use it to multiply this. So we say 2 times 1, 5 times 1, 6 times 1, 8 times 1, 11 times 1. And what will that give us? We're going to add them together. Say 2 plus 5 plus 6 plus 8 plus 11. Now we need the other box here. Now what do we do? Say 2 times 2, that will give us 4 plus 5 times 5, that will give us 25. 6 times 6 plus 36. 8 times 8 plus 64 plus 11 times 11, and that will give us 121. Now, then what do we do this? This matrix is 1, 2. We have 2 rows, and how many columns? 1, 2, 3, 4, 5. We have a 5 column. This is a 2 by 5 matrix. And here, what matrix do we have here? We have 1, 2, 3, 4, 5. That is a 2. Now 1, 2, 3, 4, 5. So we have a 5 row. Multiply by how many columns? 1, 2, 2 column. You can see that this matrix and this matrix will equally grow. The 5 here, you can see the 5 here. So we have 2 by 2 matrix, and that is all we have here. 2 row and 2 column. So this matrix here is going to give us this. So 1 plus 1 plus 1 plus 1 will definitely give us 5. 2 plus 5 plus 6 plus 8 plus, I think this is 11. 2 plus 5 plus 6 plus 8 plus 11, and this is going to give us 32. Then the same thing here, we're going to have 32. 4 plus 25 plus 66 plus 64. All this is give us 250. So we have our matrix here, which is x prime x. Alright, so we are through with this x prime x. Now later we're going to find the inverse of x prime x. We need the inverse of x prime x. Now I'll say x prime x inverse is going to be 1 over determinant of x prime x multiplied by by what is x prime x. The value of our x prime x here is this, isn't it? Now, what we're going to do here is we're going to interchange this value here. We're going to interchange this value here. That is, this 5 will come here, and this 250 will move to this side. So here we're going to have 250 and 5. Then we're going to negate the value here, which is 32, 32, and this will become minus 32, minus 32. Now, what do we need? We need to find the determinant of x prime x. So, determinant of x prime x equals to determinant. Our x prime x is 5, 32, 32, and 250. And this will be equals to the same determinant here. So, this multiply by this, so 5 times 250 minus this multiply by this, 32 times 32. Now, what do we get here? 5 times 250 equals 1250 minus this multiply by this equals 1024. Subtracting this from this will definitely give us 226. Therefore, determinant of x prime x equals to 226. Now, x prime x inverse now equals to 1 over 226 into this is a matrix here, which is 250, 5 minus 32 minus 32. So we're getting the inverse of x prime x, which means we're totally done with this x prime x inverse. Now we need x prime y. Now, what is our matrix y? Matrix y is given as this. You can see we only have one y, and these are the value of y: 8, 6, 4, 3, 1. So we have 8, 6, 4, 3, 1. So what do we know now? We'll multiply this x prime x, this x prime x, and it was x prime y, and these are our x prime. So we want to do with x prime y and say x prime y equals to, these are x prime here. So 1, 1, 1, 1, 1, 2, 5, 6, 8, 11. Multiply that matrix y, and our matrix y is 8, 6, 4, 3, 1. So what are we going to have here? This matrix here is matrix of 1, 2, 2 by how many column? 1, 2, 3, 4, 5. We have 2 and 5, and this matrix here is 1, 2, 3, 4, 5, 5 by 1. So this 5, we consider this 5, definitely the matrix is going to be 2 by 1 matrix. So we are expecting 2 by 1 matrix after multiplying this. Now let's multiply x prime y equals to, we're going to use all this row to multiply this column. 1 times 8, so 1 times 8, and that will give us 8 plus 1 times 6, 6 plus 1 times 4, 4 plus 3 plus 1. Now we've gotten the first point, and we're going to use the second row here to multiply this, and that will give us say 2 times 8, 16 plus 5 times 6, 30 plus 6 times 4, 24 plus 8 times 3, 24 plus 11 times 1, 11. So we're going to have this, and this will be equals to, so 8 plus 6 plus 4 plus 3 plus 1. This will give us 22, and multiplying the 16 plus 30 plus 24 plus 24 plus 11. That will give us 10105. Alright, now we are not going to go back to this. We've gotten our x prime y, which is this, and we've gotten our x prime x inverse. X prime x inverse is this. So we need to multiply this and this in order to get the coefficient of beta naught and beta 1. So let's move on. Alright, now it says beta equals to x prime x inverse multiplied by x prime y equals to beta naught beta 1. So our x prime x inverse is this matrix say equals to 1 over 226 into bracket 250 minus 32 minus 32 5 multiplied by this x prime y, and our x prime y is 22 105, and this will give us our coefficient beta naught beta 1. Alright, so now we're going to multiply this by this. After multiplying that like that, so this is going to give us equals to, we still have 1 over 226 also in here. Now we need to multiply this matrix by this matrix. So in multiplying that, we're going to have this. So this row multiplied by this column. Again, let me say this row multiplied by this column, that is 250 times 22. Now we have 250 times 22 plus this multiplied by this minus 32 times 105. We throw the first row, first column here. Then we need to do the first row, first column here. Minus 32 times 22. So minus 32 times 22 bracket plus 5 times 105. I say 5 times 105 equals to beta naught beta 1. So if you multiply this by this, then subtract it from what we have here, what are we going to have exactly? So 250 multiplied by 222, and that will give us equals to 1 over 226 into bracket 250 multiplied by 22 plus minus 32 times 105. If you press your calculator, you're going to have 2140. Then this multiplied by plus this multiplied by this is going to give us minus 179 equals to beta naught beta 1. So dividing this by this will give us the last value. So 2140 divided by 226, because this is going to affect both here. Then minus 179 divided by 226, so equals to, and our beta naught beta 1. This beta naught beta 1, write it here, and this will be equals to 2140 divided by 226. That will give us, by calculator, 9.4690 minus 179 divided by 226. By calculator, that will also give us minus 0.79 So it means our beta naught equals to this value, our beta 1 equals to this value. So therefore, beta naught equals to 9.4690. The beta 1 equals to minus 0.7920. And our model y equals to beta naught plus beta 1 x. And this model become y equals to beta naught, which is a 9.4690 plus, because we have our beta 1 to be minus, so it is called minus 0.7920x. So this is our line of regression, and this is the coefficient. This is the coefficient of regression, which is beta naught and beta 1. So this is the way of solving simple linear regression using matrix method. Thank you for watching.